This is the first of a couple videos on unit conversions. This is going to be more of an introduction. If you're interested in the two-step unit conversions, or when we have cubic units, as when we're doing volume or area, then look to those other videos. So one of the first things that is important when we're doing unit conversions is to be familiar with some of the more common units that you're going to be using this semester. So this isn't all the units that we're going to be using, but this is some of the more important ones. And so when you see a G, you need to know that that represents a gram and we're measuring mass. Or M represents meter, we're measuring length. S is a second, we're measuring time. A joule means we're measuring energy. So if I see 150 M, I know that's 150 meters and it's a length measurement. Or if I see 360 seconds, I know that that's a time measurement. So another one of the really important things when we're doing unit conversions is the metric prefixes. And so the nice thing about the metric system is these prefixes can apply to any of the units that we were looking at on the last slide. And so by adding a prefix to it, I can either make that unit bigger or I can make that unit smaller. Now, there are a couple things that we need to be careful about. We need to be very careful about using uppercase and lowercase. For example, here's uppercase G, which represents giga, right? Distinguish that between the lowercase g, which means gram. Or here we have capital M for mega, or lowercase m for milli. But then if you remember on the last slide, we also had lowercase m representing meter. So another important thing to remember on these prefixes is that the prefixes never appear by themselves. They always have to be in front of another unit. So for example, if I gave you 140 M, that can't be milli because milli can't appear by itself. If I just have an M by itself, then I know that that's a meter. But if I had, let's say, 25 mm, well then I know that the first number or the first letter is a prefix, and so that's telling me milli, and then the second one is the meter. So this is 25 millimeters. Right? But of course I can have these prefixes with anything. So I could also have 40 mg, and that would be 40 milligrams. And again, I know that this is the prefix because it comes first, and I know that this is my base unit for the gram. Let's look at a couple examples of doing conversions between some different. All right, so in this first example, they want us to convert 760 nanometers into meters. So whenever doing the unit conversions, the first thing I always want you to do is write down your conversion factor. So the fact that I'm dealing with nanometers, I need to look at my table and find the n, the nano, which means 10 to the minus 9. And so I can write down, because I know that nano means 10 to the minus 9, that means that always 1 nanometer is equal to 10 to the minus 9 meters. And so we're always going to compare the prefix with the unit to just the unit by itself. When I write my conversion factors, the side that has the prefix will always get a 1. The side that has the unit without the prefix will always get the corresponding power of 10. So because this is nanometer, the prefix that goes with that is 10 to the minus 9, so that goes with the meter. So once I've written down my conversion factor, I can do the conversion. So I start by writing down the number I'm trying to convert. In this case, that's 760 nanometers. And I'm going to multiply this by my conversion factor. And I'm going to take one side of my conversion factor and put it on the top, and another side and put it on the bottom. The way I decide which one goes where, so, do I put the 1 nanometer here or here? I decide that by looking at the units that I'm trying to convert. Whatever I'm starting with, that has to go on the bottom so that they cancel out. So the fact that I'm starting with nanometers, that means the 1 nanometer needs to go on the bottom. Whichever one I put on the bottom, I have to put the opposite one on the top. So because I put the 1 nanometer down here, that means the 10 to the minus 9 meters needs to go in the top. All right, another thing that we're looking out for, we're doing the U conversions, whatever we're trying to get into, that has to end up as the last unit on the top. And so what we can see now is here I've got a nanometer on the top and a nanometer on the bottom. Those cancel. There's nothing to cancel the meters, so my final units are going to be meters. So when I plug this into my calculator, I get 7.60 times 10 to the minus 7 meters. Now, one thing I should have mentioned on the previous slide, if you notice, there are a couple of these guys that I have in red. The reason I put these in red is because on the tests and quizzes, I'm not going to give you these prefixes. You're going to need to know these three. Any other ones I'll give you, but I expect you to know that kilo is 10 to the 3, centi is 10 to the minus 2, and milli is 10 to the minus 3. All right, sorry for that aside. Let's go back and do this next example. So here, we're going from 0.00235 meters into nanometers. This is the same two units that I was dealing with last time. And so the conversion factor is exactly the same. When I see meter and nanometer, it doesn't matter which direction I go, the conversion factor is always going to be that 1 nanometer is equal to 10 to the minus 9 meters. All right, now the difference is, first I'll write down the number I'm trying to convert. So the difference is, depending on which direction I'm going, that just changes which side the meter and the nanometer go on. So in this case, because I was starting with nanometers, nanometers had to be in the bottom. In this example, I'm starting with meters, so then the meters has to be in the bottom. So then I'm going to put the 10 to the minus 9 meters and the 1 nanometer. So it works exactly the same in both cases. It's just I have these guys swapped. And the way I know which one goes on the bottom and which one goes on the top is because I look at what I'm starting with. Here I'm starting with meters, so the meters have got to go on the bottom. In the first example, I started with nanometers, so the nanometers had to go on the bottom. Right? So to finish this problem off, right, our meters will cancel. I'm left with nanometers, and when I multiply that out, I get 2.35 times 10 to the 6 nanometers. All right, to finish this video up, let's do 2 more examples on the next slide. All right, in this first example, we want to convert 7.58 times 10 to the 4th micrograms into grams. And be careful, right? This is not a U. This is actually the Greek letter mu, right? So it looks like a U, but it's got this little tail in front. And micro means 10 to the minus 6. So my conversion factor is 1 microgram is equal to 10 to the minus 6 grams. All right, so then I write the number I'm trying to convert. 7.58 times 10 to the 4th micrograms. And because I'm starting with micrograms, I need to put micrograms on the bottom. So I take my 1 microgram and put it down here. And then that's 10 to the minus 6 grams. And so when I multiply that out, I get 0.0758 grams because the micrograms have canceled. I'm left with just grams. All right, in our last example, I want to convert 867 seconds into megaseconds. So I look at my table. I'm dealing with the prefix mega. So here's mega. 10 to the positive 6, so that means that 1 megasecond is equal to 10 to the positive 6 seconds. So I start with my 867 seconds. Because I'm starting with seconds on the top, I need to put seconds down here, so my 10 to the 6 seconds will go down here. That means the 1 megasecond has to go on top. So those will cancel, and I get, when I multiply that out, 8.67 times 10 to the minus 4 megaseconds.